In this video, we're going to go through trig proofs, which is proving that the left-hand side of an equation equals the right side or vice versa. In order to prove an identity, there really is no one way to do it, so I just have some guidelines listed below. Generally, you want to start with the more complicated side of the equation, and you want to rewrite things using basic identities like I have here in this center table for you, to rewrite unlike functions in terms of the same function. You want to remove parentheses by using distribution, perform operations like adding fractions, finding a common denominator. Usually that'll help you. Factoring sometimes helps too. You could multiply by conjugates of the denominator, simplify complex fractions, and lastly, just don't assume what you're trying to prove. And what I mean by that is don't work on both sides. You want to see one string of equations that leads you from the left side of an equation to the right side, or vice versa. So what you're going to see in the following examples are some of these strategies being put to use to see how I would solve these. Now, you may think of something that is different than what I do, and that's fine. Like I said, there's really no one way to always solve these. So let's look at the first one. I've got cosecant theta, cosine theta equals cotangent theta. So I'm going to start with the left-hand side here and just start rewriting things. I've got cosecant, which I can rewrite as 1 over sine of theta. And cosine of theta, I'll just leave that as is. Now when I multiply these, so multiply numerators and denominators, I get cosine of theta over sine of theta, which is cotangent theta, which is what I was trying to get on the right-hand side. And that one's done. Okay, now if I come down to number 2, I see tangent, sine, and cosine. Well, I'm going to try and just rewrite everything in terms of sines and cosines and hope that it'll help me here. So tangent of x I can rewrite as sine of x over cosine of x. And then I still got it times sine of x. I'll just put that over 1. Plus cosine of x. So when I multiply this out, I get sine squared x over cosine x. At this point, I would just add the fractions. Let's see if that helps me. So I'm going to need a common denominator. If I multiply the top and the bottom here by cosine of x, to get my common denominator of cosine of x, I would get sine squared x plus cosine squared x all over cosine of x. Now, sine squared x plus cosine squared x is an identity. That's the Pythagorean identity. So sine squared x plus cosine squared x is 1. And so I get 1 over cosine of x. And what is 1 over cosine of x? Well, that is secant of x. And that's exactly what the right-hand side is, and that's where I was trying to go with this. Come back up here to number 3. Okay, this would be one of the strategies where I try to get rid of the parentheses by using distribution. So starting on the more complicated side here, I've got cosine theta times secant of theta minus cosine squared theta. Okay, now I see the secant. I can rewrite that as 1 over cosine, and then I can get some stuff to cancel. So the cosines will reduce to 1. So I've got 1 minus cosine squared theta. Now if you peek back up at our Pythagorean identity, well, if I have sine squared x plus cosine squared x equals 1, and I have down here 1 minus cosine squared x, 1 minus cosine squared x must be sine squared x, just by subtracting cosine squared x from both sides in this equation. So right over here then, I know that 1 minus cosine squared x is sine squared x, or sine squared of theta. All right, so now take a look at number 4. Okay, so a couple things I could do here. I could try to add the cotangent of theta and tangent over tangent of theta plus 1, Or I can look at the cotangents and tangents and try to rewrite in sines and cosines. Typically that's usually what I do because I want to try and get stuff to cancel. So I'm going to rewrite cotangent of theta as cosine of theta over sine of theta. Then all of that divided by sine of theta over cos of theta. And I still got the plus 1. Now if I'm dividing fractions, I'm really multiplying by the reciprocal. So I keep the first guy the same, continue to change it to multiplication, and then do the reciprocal of the denominator. Okay, so nothing cancels, but what I do get is cosine squared theta over sine squared theta plus 1. Now peek back up at the right-hand side here with what you're trying to do. I'm trying to get to cosecant squared theta. So if I peek back up at my identities, cosecant squared theta is 1 plus cotangent squared theta. I have a 1 plus down there. So I've got 1 plus, so what is cosine squared theta divided by sine squared theta? Well, that would be cotangent squared theta, which is what I wanted above, so cotangent squared theta, so kind of to come over here, cotangent squared theta plus 1 is cosecant squared theta, which is where I was trying to go with this. All right. Now coming down here to number 5, cosine squared x equals cosecant x times cosine of x all over tangent of x plus cotangent of, whoopsies, x. My x fell off there. All right, so the more complicated side in this one actually looks like the right-hand side, so that's where I'll start. I'm going to start rewriting things in terms of sine and cosine. So I've got, let's see, 1 over sine of x times cosine of x over 1, so I'll just leave it like that, all over tangent of x is sine of x over cosine of x plus cotangent of x over sine of x. Remember, I'm trying to get to cosine squared of x somehow. Now, one of my rules is just perform the operations that it wants to do. So in the numerator, I've got cos x over sine x all over. Now, if I want to add stuff in the denominator, I'm going to need a common denominator between these two fractions, which looks like it would be cosine x sine x. So I'm going to multiply, oh, I just realized that I wrote cotangent here. That's supposed to be cosine. There we go. All right. So back to what I was saying. I need a common denominator of cosine of x sine of x. So I'm going to multiply the top and the bottom here by cosine of x. Cosine of x over cosine of x, I should say. And then top and bottom here also by, well, now by sine of x. So sine of x over sine of x, which is essentially multiplying by 1 in each of these. It's like multiplying by 2 over 2 or 3 over 3. I'm just changing the way it looks. So now I have sine squared x all over, well, I'll say plus cosine squared of x, because now I have the common denominator of cosine of x sine of x. Now this looks promising because I know that sine squared of x plus cosine squared of x is 1. So I'll rewrite this again. Cosine of x over sine of x all over 1 over cos x sine x. Now if I want to divide fractions, I got to multiply by the reciprocal. All right, and it looks like then my sines will reduce to 1 or cancel, and that leaves me with what I was trying to get to, although it kind of went off the screen here. I was trying to eventually get to cosine squared x, and that's what I ended up with. Now in the last few minutes of this video, I want you to try a problem on your own. So pause the video and then you can play to get the answer. I want you to try and prove the following identity. So remember, go back to the rules, see all the other solutions that we did, and see if you can prove that the left-hand side here equals the right-hand side. Alright, so hopefully you paused the video and you gave this a try on your own. Here's how I did it. I saw the cotangent and I decided to rewrite that as cosine of x over sine of x, just to get everything in terms of similar trig functions. Okay, so then I'm going to multiply those fractions here, because maybe that'll help me, and I get cosine squared of x all over sine of x. Okay, still not quite at cosecant of x, which I know is 1 over sine of x, so maybe I'll get there somehow with adding fractions. So if I think of this as sine of x over 1, I can get a common denominator of sine of x by multiplying the top and the bottom of this fraction by sine of x. So now I get cosine squared x plus sine squared x all over sine of x. And that was really my missing piece there, because now I have this Pythagorean identity, which gives me 1 over sine of x, which is then cosecant of x, which is where I was trying to prove, or what I was trying to prove in this. I hope this video helped and gave you some ideas on how you can solve trig proofs, so that you can prove the left-hand side is equal to the right-hand side.